Is the pathway to innovation a journey we walk alone? Or are there unseen forces and helping hands guiding us along the way? Well, today on Tech Talks Daily, I want to explore the world of advanced technologies with Mike Finelli, Chief Technology and Innovation Officer at Syensqo. Now, Mike brings over 3 decades of experience in the chemical industry and also stands at the forefront of the green energy transition. And today, I want to learn more about how Syensqo and more than 2,000 scientists around the world are transforming chemical production through cutting-edge AI and are also spearheading the development of lithium battery materials, which of course are essential for the next generation of electric vehicles. And Mike will also share personal insights on some of the pivotal figures and principles that have shaped his career and vision. So buckle up and hold on tight as I beam your ears all the way to Georgia, where Mike is waiting to join us today. So a massive warm welcome to the show, Mike. Can you tell everyone listening a little about who you are and what you do?
Thanks, Neil. Really, it's a pleasure to be here. So I'm Mike Finelli. I'm the CTIO, that's Chief Technology and Innovation Officer for a company called Syensqo. I'm also the Chief North America Officer, so I overlook our operations in North America. So what do I do? The primary role that I have is the CTIO role, which is to oversee our 2,000 scientists. Syensqo is a brand new company. We're about 5 months old, but we have a 160-year history. So we're a spinoff of a company called Solvay. And we have 2,000 scientists. We call ourselves explorers looking for the next scientific breakthrough. And as you can see from the name, Syensqo, spelled Syensqo, science is in our name.
What an incredibly cool name and cool story too. And for people just hearing about you guys, as you said, Syensqo, you're explorers ultimately, experts in science that are ultimately just passionate about all its possibilities. And just to set the scene for our conversation today, with the upcoming groundbreaking of Syensqo's flagship site in Augusta, I've got to ask, how do you envision this facility contributing to the US clean energy landscape, and particularly within the battery belt too? And we do have a lot of people listening all around the world, so you might want to expand on what that is too.
Yeah, so as you just mentioned, we broke ground, I should say, late last week, right? It was Thursday last week. We had a fantastic ceremony. We had attendees from the White House, from the Department of Energy, local government. We had our customers there. Most of the battery customers that you've probably heard of were in attendance, and our partner Orbia, who is also critical to this project. We have a joint venture, and they're bringing the key critical minerals to the table for this investment. The goal here that we're doing is we're building a really important product that's required for the battery performance of a lithium-ion battery. What this product is, it's called PVDF, and it's a binder for the cathode. So think of it as a glue that keeps all the ingredients inside the cathode together, doing the job they're meant to do. And our materials are the most advanced out there, and they allow the battery maker to put more active ingredient into the battery, increasing the energy density. What does that mean for the average person driving a car? It helps extend the range of the vehicle, so it helps solve range anxiety. What's exciting about this plant is it's really helping to build this battery infrastructure in North America. The entire supply chain is coming from North America, from the critical mineral that I mentioned, all of the upstream raw materials, the major key raw materials. We're building together with our partner Orbia. Part of those plants will be in Louisiana, and then the finished product will be, as we talked about, in Augusta, Georgia. And having this local infrastructure is critical for the North America battery industry. Everybody's worried about sustainability, and having global supply chains. One, you got to worry about reliability. When things like the Suez Canal, when that ship got stuck, that shut down all the supply chains around the world. When unfortunately, there's conflict in the world, that gets in the way. And also sustainability, right? More and more, our customers are asking us to be sustainable. So producing locally, we reduce the carbon footprint of the supply chain, which is really, really important. So having this plant in the United States will allow us to supply up to 5 million electric vehicles by 2030. So it's really exciting, and we're happy to be part of it. And we're happy to receive a $178 million grant from the Department of Energy, which really helped us make the decision to put this plant here in the United States.
And one of the things I think I should highlight, having done a little research on you before you came on the podcast, is that 80% of Syensqo's innovation pipeline is all driven by sustainable solutions. And we're hearing a lot about sustainability, ESG scores, decarbonisation, etc. So I guess the big question I should be asking you on behalf of everyone listening around the world is, how are these innovations helping to tackle the challenges around decarbonisation? And what are some of the specific advancements that maybe you're most excited about?
Absolutely. No, Neil, thanks for bringing that up, because it's something that we do at Syensqo. It's not done by many companies out there. We do what's called a sustainable portfolio matrix, right? So SPM, we call it. And if you think of it as a vertical and a horizontal axis. On the vertical axis, we're looking at about 20 different factors about the product that we're going to innovate. Because you mentioned that, 80% of our portfolio is in what we call sustainable solutions. So I think it's important to explain what that is. So on the vertical axis, we look at about 20 different factors about the product that we're going to design and make. What's the carbon footprint of that process? We call life cycle analysis, right? From the manufacturing, the energy consumption, the water consumption, waste emissions. We look at all of these different factors. And then on the horizontal axis, we're looking at the value that it brings to the customer with respect to sustainability. Is it helping them reduce their carbon footprint? Are we bringing a product to the market that's going to help with an energy transition to get away from burning fossil fuels, for example? So we look at about 60 factors on that side. And when you plot these two into a matrix, you look at where you have a very low carbon footprint on the product and a very high value for the customer or the industry from a sustainability standpoint, and you end up in the bucket that we call sustainable solutions. So we're looking at applications, and we're looking at designing molecules that bring products to the market that help our customers decarbonize their footprint. You asked about examples of what else we're working on. So we talked about lithium-ion batteries, obviously materials that help batteries go further, materials that help next generation batteries like solid state batteries. That's the holy grail of batteries. We have the first pilot plant in Europe to make sulfide chemistry, which is the leading technology for solid electrodes. This will allow batteries to have a range of 600-700 miles with very fast charging, very safe profile. That's a little bit further down the road, probably end of the decade. The other area we're spending a lot of our research and development is in green hydrogen. Some people say, we don't like the colors, green, blue, gray. Let's just say zero emission hydrogen, right? So clean hydrogen, but we're talking about zero emission hydrogen. What we do here is we develop the ionomeric, it's an ionomer membrane that actually is the membrane that splits water, H2O, into H and O. And as long as you charge that electrolyzer with green energy, so solar or wind, you produce hydrogen with zero emissions. And then on the consumption, you have a fuel cell, or you can burn the hydrogen directly. In the fuel cell, we have the same membrane, and you recombine the hydrogen with oxygen from the air, and you generate energy, and you have water as the only byproduct. So you have a complete circular loop. We start with water, we end with water, and as long as you use green energy to drive it, you have a completely zero emission technology. And I think it's pretty clear, if we want to get to carbon neutral by 2050 or beyond, we're not going to do it without a clean green hydrogen economy. And Syensqo goes right in the middle of that.
And I love how you're using technology here to drive positive and meaningful change that can impact our world that we all share here. And also, as electric vehicles, obviously, they're gaining momentum. I was also reading how PVDF, that plays a pivotal role in electric vehicle batteries, particularly in enhancing their range and efficiency. And you gave some great examples there a few moments ago. But can you explain the technological edge that Syensqo's PVDF binder offers what it offers differently from other materials currently available in the market?
Appreciate the question. So yeah, that's the plant that we're building in Georgia that we had the groundbreaking ceremony on. And as we said, PVDF it's a polymer. It's a fluorinated polymer that can withstand really high temperatures. It's got super stability, non-flammable. And when you put this in there as a binder in a lithium-ion battery, it allows the battery to charge faster. Because when you ever plug your phone in and charge it, and when it's done charging, you touch it, it's warm.
Yeah.
Well, that's the energy going in. Now imagine a car battery, which is you need to charge it quickly. You start putting a lot of voltage into that to charge it quickly. That battery gets really hot, and other binders they fail. They stop working. They can decompose. The PVDF can handle that environment, right? Now, there are other people that make PVDF out there. So what makes our PVDF better? And by the way, PVDF has been the standard material in lithium-ion batteries as the binder for over 20 years. So this is something we developed the concept 20 years ago for the industry. But we're continually inventing new PVDF molecules that are better glues. Remember earlier I mentioned, think of it as the glue that keeps all the ingredients together. The better it acts as a glue, the less you need, right? So they're always looking at, how do we reduce costs? So if we can reduce the amount of PVDF that's needed, they can also put in more active ingredient, which is critical. So we make better binders, if you will, that allow the battery maker to put more active ingredients together in the battery, which allows them to extend the range of a battery. Everybody wants a battery that goes further, right?
100%. A question I've got to ask is a company that's right at the forefront of EV battery materials development. What would you say are the next generation battery technologies that you believe will significantly impact this industry? And how are you at Syensqo contributing to some of these developments? Because it feels like a really exciting space right now.
It is, Neil. It really is. And what I would say is the industry has a roadmap, right? Today, the cars that are driving around, they have some of them have what we call Generation 2 batteries, right? And some newer ones are having what we call Generation 3 batteries, which are higher voltage batteries and have a higher energy density. And that's something that I think will take over the next couple of years. And what you have here is what we call high voltage batteries. It may sound strange, but just moving the voltage of a cell, right? So keep in mind, a battery is made up of a bunch of small cells, whether they're cylindrical or pouches. There's a variety of different types. Increasing that from, 3.6, 3.7 to 4, 4.2 doesn't sound like a big jump, but it's a huge gain in energy density. The problem with that is the materials that go into the battery, into the cathode and anode, they need to change because they need to handle higher temperatures for charging. You want fast charging. People talk about fast charging a lot. When you start charging, you start putting higher voltages, you need more stable ingredients in the batteries. You need better binders, which we already talked about, we're working on, but you need new salts, right? So in a cathode, you have the cathode active material, but you also have salts, you have solvents. You need solvents that are non-flammable. You need electrolytes that and salts that can handle the higher temperature range and stability. And we're working on both of those. So we have a product called Energain, which is a solvent, a replacement solvent for the batteries today, and it's significantly less chance of fires. And we also have the next generation salt, which will be more stable for high voltage batteries and faster charging, called LiFSI. And this is a new electrolyte salt that we're developing and planning on bringing to the market in the next couple of years. And as I already mentioned, for the Holy Grail, the next generation we call Gen 4 batteries. This is the solid state batteries, right? This is where you don't have any liquid electrolyte anymore. And the electrode itself is a solid material. So we already have, as I mentioned, the first pilot in Europe. We're making sulfide chemistry. So that's the material that will be the solid electrode. And this has the potential to bring batteries to the market with ranges in the range of, 600-700 miles, 1,000 kilometers if you do metric. So really, really exciting future. And these batteries will charge faster. They'll be safer with much further range. So that's kind of the roadmap for the next decade or so. And Syensqo goes right in the middle of it, bringing the key materials to the market.
And there's also a lot of hype around AI right now. And on this podcast, I always try to get people thinking beyond that hype and learning more about how it's solving real world problems. And this is something else that put you guys on my radar, leveraging AI in chemical production and how that can lead to transformative efficiencies and breakthroughs. So can you expand on that and maybe share how Syensqo is integrating AI into your processes and And maybe share any notable outcomes of this strategy as well, because as I said, there's so much hype around this at the moment, but these real-world examples, real-world stories of a huge difference that you can make. Again, it's incredibly exciting, isn't it?
Well, I'm glad you asked that question. I got to tell you, I'm really passionate about AI. I love it. And I see tremendous potential. Now, we'll talk about what we're doing now and what we see potential for the future, but Syensqo, and as I said, our predecessor Solvay, we were a spinoff, as I mentioned. We've been using AI and machine learning for over a decade now, and we've been using it in our plants to improve our quality. When you have at a chemical plant, we collect literally tens of millions of pieces of data over the year, right, during production, and you find out when this happens in a lot of different manufacturing, right? All of a sudden you have super good quality, you have great quality, you have great yields. You get what we call the golden batch, right? So you get a production run that just is the best you've ever seen. And you want to know, well, how do I duplicate that, right? Ultimately, if you could duplicate that, you can improve your quality consistently. You can improve the yields of your plants. So what we do with AI is we use the AI to crunch the data, the millions of pieces of data that come from a plant, and we understand why, and we use the AI and the machine learning to understand why we were able to produce that. What were the temperature? What was the special little conditions that allowed that to happen? And then what we do is, with typically minor investment, we're able to make sure that we hit that every time. We've seen improvements in quality. Significant improvements in quality. We've seen 20-30% improvement in yields out of the plant. So we've been doing this type of work for years, right? And that's a very effective way of using AI. But what's exciting to me is the next generation, right? So the big hype, and if you read, you're reading, and I know you're very familiar with it, is the generative AI, right? 5 years ago, people were saying, wow, AI is never going to be able to create. It's never going to, a lot of people talked about music or art. Well, that's not our interest, music or art. I mean, it's very exciting that it can do that. But what I like, it can create design of molecules. It can create interesting experiments that we may not have thought of. So one of the things I see for the future is, how can we use generative AI to help us create new molecules, right? It's being done in the pharmaceutical industry. You've probably read universities or they've come up with, 1 million different molecules, and they've used the generative AI to develop them, but then narrow that down to a handful that are manageable, that, they think are the best chances of success to deliver the performances that you're looking for. So that's how we'll use this. I see it as a way to help us create new ideas, but also when we run an experiment, we have to run sometimes 100, 200, 300 experiments to narrow it down to the prototypes that we want to start sampling customers. But with generative AI, we should be able to predict the molecules and design the molecules that have a better chance of success. So I could reduce the number of experiments down to tens instead of hundreds. And if I can do that, I can bring solutions to my customers faster. And that's super exciting for us and super exciting for the customers.
So in your role as Chief Technology and Innovation Officer, I'm curious, how do you balance the push for rapid innovation with the operational demands of managing such a vast team and tech portfolio right across North America? Because I would imagine it's not as easy as it sounds, and it is quite a tricky balance sometimes.
It is a tricky balance. And these 2,000 scientists, by the way, are spread all around the world. I mean, I oversee North America from an operations, but the CTIO role is global. And we have about 25 R&I centers around the world. So coordinating these teams is not particularly easy. But we have teams that are developed around technologies, right? So we have what we call global business units. And there are teams that work on, for example, in our business unit, NovaCare, it's called. They're doing a lot with shampoos. So if you shampooed your hair this morning, chances are a 25% chance you used Syensqo ingredients. That team, we have a team there working on the next generation ingredients that go into shampoos and go into conditioners, and that are going to be bio-based and or biodegradable by design. So we have teams that are focused around that, biodegradable by design. We have a platform called Biotechnology and Bioresources, This platform is focused on using biotechnology. So we actually take microorganisms like bacteria, proteins, enzymes, and we program them, if you will, right? So we change the DNA, and then we do fermentation processes with these microorganisms to generate chemistry that we can then use in our products. So there's another platform we talked about that's around green hydrogen, as I mentioned, and we have another platform around the lithium-ion batteries, which we've talked a lot about, and a fourth one around lightweighting, which is thermoplastic composites. So we kind of build our 2,000 scientists are built around, designed around technologies and businesses. So that's kind of how you kind of have to attack it, and you break it down into pieces. And then there's a lot of support that goes across both, right? Because there's certain expertises and certain skill sets that we need that are kind of universal. So at the group level, at the corporate level, we'll keep some of that expertise there, and we'll support the different businesses as needed.
So if we were to look ahead, what would you say are some of the key challenges and opportunities that you see for the chemical industry and its journey towards greater sustainability, towards technological integration? What excites you there, and what obstacles do you see in the way that you're overcoming?
So there's something that, I'll start by saying, the chemical industry is the mother of all other industries, right? I really challenge people to find anything that, anything man-made in their life, that look around the room you're in, look around your house, point to anything in there. I challenge you to find anything in there that didn't come from, at least in the beginning, from the chemical industry. And because of that, it's the chemical industry that's going to bring the new materials that are low carbon. We're going to bring the new technologies that help us decarbonize the planet. So when I look down the road, I see tremendous opportunity for the chemical industry, right? I mean, there's a lot of things coming together. There's the energy transition, there's electrification, there's AI, generative AI, automation. I've been doing this 30 years, right? And when all of these things, I've never seen this many megatrends coming together. And to get us there, the foundation is going to be built by the chemical industry. So that really excites me, and that's what gets me up and gets me going in the morning.
Yeah, I completely agree with you. We hear a lot around megatrends, emerging technologies, what they mean, but as you said there, when they all begin to converge, that's where the magic happens. And we started the podcast today talking about you, your origin story, and the great work that you're doing. But I'm now going to ask you to look back at your career, because I think none of us are able to achieve any degree of success without a little help along the way. Very often it's someone that just sees something in us. Maybe they invest a little time into us. So I've got to ask, is there a particular person that you are grateful towards that maybe helped you get you where you are today? And we'll give them a little shout out. But who would that person be and why?
Now, that's a great question. You're absolutely right. I mean, no one gets to where they are in their career without help. And I've been fortunate enough. I've had many mentors at different points in my career, to help me get to where I am. But I would say, somebody I'd love to shout out to. It's probably I've worked with two different people on this concept. And I'd say it was over the last 5 years. It really helped me be a better executive. And it's a group called Insight Principles. The guy I've worked with the last couple of years is a guy named Robin Sharbit. He's up in Massachusetts, and these guys really all they teach you, and they'll say this. I mean, I don't want to make it sound funny, but really all they teach you is how your mind works. And once you understand how your mind works, you realize that most of the time, people are in a state of stress, right? We're the only animal on the planet that lives in a heightened state of stress most of our time. And when you learn how your mind works, you realize that stress is completely optional. The suffering in life is optional. And it's usually created by yourself, by your own ego getting in the way, and by being busy-minded. And when you realize how your mind works, you can clear all that out and let your mind do what it was designed to do, which is solve problems. So these guys changed my life. And another guy that I worked with in the beginning, a guy named Ken Manning, together they really changed my life and my outlook and how I am as a leader. They got a book out there. I don't get any money for the book. It's called Invisible Power. Take a look at it on Amazon. And It's not a very complicated book, but I tell you, it's some really insightful things.
Wow, what an incredible answer. Big shout out to Guy, Ken, and everyone at Insight Principles. And I also have an Amazon wish list here where I always ask my guests to leave a book. So I'm going to add their book, Invisible Power, to that list as well. But anyone listening just wanting to find out more information about Syensqo, the work you're doing, the things that we talked about today, maybe even connect with you or contact your team, what's the best starting point for everything?
Well, I think we have our website out there. You can reach us through there. You can also just connect with me on LinkedIn. Great place to find me, and happy to connect with people.
Well, I'll add links to everything to make that easier for everyone listening. And I learned so much today from you, from accelerating the green energy transition, leading in EV battery materials development, and also leveraging AI by embracing the digital transformation of chemical production. And I suspect most of all, little did I know when I got up and washed my hair this morning that the shampoo I used contained Syensqo ingredients. But just a big thank you for sharing your incredible insights today. Thanks again, Mike.
Absolutely. Thanks a lot, Neil. Thanks. Appreciate being on the show.
I cannot thank Mike enough for coming on here today, because I've gained so many unique insights into how Syensqo is pushing the boundaries of innovation in the chemical sector. And this is an area that I'm not too familiar with, and that's why I sit down and have these conversations every day. Because I think it's inspiring to hear how they're driving forward this clean energy transition, the role of technology doing that, and also shaping the future of sustainable technology as well. But how do you see AI and advanced materials influencing your industry? These are the stories I love to shine a light on, so please email me now, techblogwriter@outlook.com, Twitter, LinkedIn, Instagram, just at Neil C. Hughes. But that's it for today, so thank you for tuning in, and as we look forward to bringing you more stories that connect technology, innovation and real-world impact, I cordially invite you to join me again tomorrow. But thank you for listening today, and until next time, don't be a stranger.